On June 9, 2026, Anthropic released Claude Fable 5. 3 days later, a United States government export directive forced it back offline. Fable 5 launched with a 1 million token context window and a benchmark-setting 82.1% SWE bench score, positioning it as a model optimized for autonomous, long-horizon work. Within 48 hours, the Department of Defense halted its use, and Microsoft removed the model from its internal Copilot Foundry environment. The suspension exposes a direct architectural collision between the requirements of autonomous AI and the constraints of standard data security protocols. The specific engineering leap required to achieve this level of autonomy triggered a compliance crisis that current government frameworks cannot resolve. Expanding a context window to support autonomous agents increases the internal complexity of the model's self-attention, which in turn expands its adversarial attack surface. To secure this expanded surface, AI labs are removing zero-retention data policies and introducing breaking changes to standard API response structures. These new security measures are structurally incompatible with the privacy standards used by the largest enterprise and government organizations. To understand why this friction is unavoidable, we have to look at the underlying mathematics of the transformer architecture itself. Managing the tension between context size and compliance is the new mandatory baseline for deploying enterprise-grade AI. This diagram visualizes the scale of the Claude 5 generation. Its primary differentiator is a 1 million token working memory. That massive capacity enables dev team mode. A master agent can ingest an entire codebase at once, delegating parallel testing and research tasks to multiple subagents. Through the Model Context Protocol, these agents share data and record their progress to persistent state storage. The master agent then autonomously reviews logs and verifies the outputs of its subagents before completing the user's request. Executing this workflow requires keeping the code, the instructions, and the status of every active agent in memory simultaneously. True AI autonomy is defined by the capacity to hold an entire system architecture in active memory. Maintaining this active memory introduces a structural engineering cost that legacy security cannot address. To understand an input, a transformer model calculates the relationship between every individual token and every other token in the sequence. Compute requirements scale quadratically with sequence length. As the window expands, the number of internal connections multiplies exponentially. This quadratic growth creates a vulnerability known as many-shot jailbreaking. Adversaries exploit the expanded window by hiding malicious logic deep within massive blocks of benign text. Real-time safety filters built for isolated requests cannot effectively parse the billion of potential relationships within a single 1 million token prompt. The volume of token relationships creates blind spots where distributed attacks go entirely unnoticed. Legacy security methods prove ineffective when malicious patterns are distributed across a sequence of this length. Anthropic's solution for Fable 5 relies on cross-request safety classifiers. As this diagram shows, these classifiers analyze behavioral patterns sequentially across multiple separate requests. Stateless filters judge every query in a vacuum, meaning they miss distributed campaigns, like state-sponsored espionage, that unfold over 50 separate prompts. For these new classifiers to work, the model must maintain a record of past requests. Anthropic has enforced a mandatory 30-day retention window for Fable 5, revoking the zero data retention option for all users. Retained prompts and outputs are fed into safety classifiers to monitor for extortion or jailbreak patterns that a real-time check would miss. Securing an autonomous model against its own massive context forces the vendor to structurally retain enterprise data. This mandatory retention led the Department of Defense to designate Anthropic a supply chain risk. For high-security environments like Microsoft Foundry, a 30-day window violates the internal standards for zero-retention data handling. These security measures also alter the architecture of the API response itself. Legacy models generally handle safety blocks by rejecting the request with a standard HTTP 400 error. Fable 5 instead returns a successful HTTP 200 response, even when it is actively refusing to fulfill a request. As we see in this JSON payload, the refusal details are now nested inside the message under the stop reason parameter. This formatting change breaks existing middleware, forcing engineers to completely rewrite their payload parsing logic. Upgrading to the Claude 5 generation requires a simultaneous overhaul of both corporate privacy policy and low-level API handling. Practical implementation now falls to systems architects, who must deploy these models despite the administrative friction. Engineering teams are forced to build robust client-side fallback routing. In this workflow, a refused Fable 5 request is dynamically rerouted to a separate model, such as Mythos 5, to ensure the application remains functional. Architects must also implement strict audit trails for any MCP artifacts that write to persistent storage. Operating at this scale demands bespoke middleware to handle the complexity of agentic state and dynamic routing. Hardware infrastructure is no longer the primary bottleneck. Modern TPUs can provide the necessary compute for million-token sequences. The defining challenge for the next generation of AI is data governance and the management of persistent state. The trade-off is structural. A million-token agentic autonomy is currently incompatible with stateless, zero-retention privacy. AI engineering now requires building architectures that respect both the advanced logic of the agent and the strict data boundaries of the organization. Maintaining a competitive edge in AI now requires engineering state-aware systems rather than simple stateless wrappers. Securing massive context windows and bridging the compliance gap is the new core discipline of modern AI development.